Last week, I did some deep coverage on some Anthropic issues. In particular, it seemed like Claude was behaving much dumber. Thankfully, for once, Anthropic actually came out and admitted that that did happen, but they admitted this multiple days later after confirming that this outage had occurred for weeks, 3 times. There were 3 separate major issues that compiled on top of each other that made most Anthropic models a lot dumber a lot of the time. And they finally decided that hiding all of the details behind the scenes might not be the best call. I complained about this a ton in my video last week, and I'm very thankful to say Anthropic has responded. They actually took the time to put up an article discussing the 3 recent issues that occurred, causing Claude models to be way dumber. This is a level of transparency I've never seen from Anthropic. Usually their transparency is limited to their research and their benchmarks for different misalignment tests. I've never seen them go this in depth on their own infra, on what problems they have behind the scenes, and actually talking about the work that the engineers are doing and what failed, and more importantly, why. To be very, very clear, it does seem like the Claude models are now back to behaving as expected. That doesn't mean you're getting a refund, which is annoying, and it doesn't mean they won't have issues again in the future, which is scary. I'm thankful to have actual information on what went wrong here, especially considering the severity of this bug and how long it was going for. All of that said, I'm not getting a refund either, and someone's got to cover my Claude code bills. So quick word from today's sponsor, and then we'll dive in. There's a fundamental problem with most of the AI coding tools we use today. They're being built on the inside, not the outside. What the heck do I even mean? Well, most of the tools that we use, things like Cursor, Claude Code, and more, are built inside of existing things. Cursor is built inside of VS Code. Claude Code is built inside of the terminal. They're limited by the shell that they're built within. What if they weren't? What if someone rethought the whole shell to build a better experience from the outside so they could make something truly incredible? Well, we have an answer, and it's today's sponsor, Warp. They built an all-in-one agentic development environment, everything from the terminal to the code tools to so much more. The terminal experience in and of itself is magical. Just having good autocomplete and history management in a terminal is so cool. But then you press Command-I, and now you can ask it to do things to the code. You can attach context with a hotkey. You can navigate everything with hotkeys. It's really focused on power users and developers, us. And it feels fundamentally different as a result. You never feel like this is being stuffed in somewhere. You feel like the whole tool is built to be a good experience for this way of building. This is a real project I spun up using Warp, and this is a real prompt that I sent asking it to do my classic image generation tool, and the results are stunning because the results are all using GPT-5. I don't have to use GPT-5. You have access to all the major models you'd ever want and more. But the fact that you get 150 free requests with any of those models is a pretty good deal in and of itself. It's still so cool I can just ask it whatever, and if it needs to run a command, it will, and if it doesn't, it won't. Obviously, it knows modern tools like Next.js and Tailwind, but if you're using things it doesn't, you can add that to the rules or the MCP servers that are global for the entire thing. So you can make it generate and run bash commands based on things that it learned about an MCP server. That's so useful and makes MCP actually feel valuable to me. There's a reason so many engineers are making the move to Warp. It just makes you more productive. Check them out now at soydev.link/warp and get your first month for 70% off with code Theo. A postmortem of 3 recent issues. This is a technical report on 3 bugs that intermittently degraded responses from Claude. Below, we explain what happened, why it took time to fix, and what we're changing. Between August and early September, 3 infrastructure bugs intermittently degraded Claude's response quality. We've now resolved these issues and want to explain what happened. I'm sure there's no particular reason why you want to do that now. Definitely not. In early August, a number of users began reporting degraded responses from Claude. These initial reports were difficult to distinguish from normal variation in user feedback. By late August, the increasing frequency and persistence of these reports prompted us to open an investigation that led us to uncover 3 separate infra bugs. Let's be clear about this. The bugs started in early August. They assumed that they were all just bad feedback, and they didn't have any evals or tooling or checks that could confirm the performance had degraded. I know LLMs are non-deterministic. I'm very aware of the fact that you can't really guarantee a result with any of these things. But I would hope you're running enough tests in the background about just random checks, maybe run 10 a day, just seeing what the outputs look like and seeing if the regularity of correct responses goes down. Did they really not have anyone running benches internally that they noticed a degradation from? Because this is scary, that it went on for almost a month, that early August they mostly ignored it, and then by late August, the increasing frequency prompted them to look into it more in depth. To state it plainly, we never reduce model quality due to demand, time of day, or server load. They do inadvertently reduce model quality in order to give their researchers more GPUs, which we'll talk about throughout this, but the problems that users reported in this case were due to infrastructure bugs alone. The reason they were making the infra changes that caused these bugs is definitely worth going into, but I will say up front, some of my previous assumptions in my last video were wrong. I had pretty confidently asserted that it seemed like their attempts to fix it caused more bugs. That does not appear to be the case, and we'll go in depth on that momentarily. We recognize users expect consistent quality from Claude, and we maintain an extremely high bar for ensuring that infrastructure changes don't affect model outputs. In these recent incidents, we didn't meet that bar. Following postmortem explains what went wrong, why detection and resolution took longer than we would have wanted, and what we're changing to prevent similar future incidents. We don't typically share this level of technical detail about our infra. Yeah, no shit. But the scope and complexity of these issues justified a more comprehensive explanation. I agree. Thank you for doing this. I hope it sets a trend. There's no reason to hide these details. It doesn't cost you anything to share this information. I don't know why you waited so long to do it. It almost feels like you were waiting until the investment round closed. Like, seriously, it doesn't make sense to hide this information. How we serve Claude at scale. We serve Claude to millions of users via our first-party API, Amazon Bedrock, and Google Cloud's Vertex AI. We deploy Claude across multiple hardware platforms, namely AWS Trainium, NVIDIA GPUs, and Google's TPUs. This approach provides the capacity and geographic distribution necessary to serve users worldwide. Each hardware platform has different characteristics and requires specific optimizations. Despite these variations, we have strict equivalence standards for model implementations. Our aim is that users should get the same quality responses regardless of which platform serves their request. This is particularly funny because I find that all of the other platforms are slightly more reliable than Anthropic's, especially after all of this. If you're not already familiar with OpenRouter and you're watching this video, you should be familiar with OpenRouter. They show all of the different providers that you can use Claude Sonnet 4 with, for example. And here we can see that Bedrock's actually quite a bit faster, has really good uptime now. It wasn't for a bit, but they've seemed to have fixed it on Bedrock's side. Google Vertex has pretty solid throughput, also really good uptime. And then Anthropic has the slowest speeds of any of the providers, and right now their uptime is decent, but that is not always a guarantee. Even just 2 days ago, it was at 99.6%, which is kind of scary. Yeah. Uptime is far from a guarantee. What's cool with OpenRouter is it'll automatically bounce your traffic between the different providers depending on what ones are most or least reliable at a given time. They all cost the same, so who cares? That said, when Anthropic's having issues, you can hop to the other providers, which likely aren't. Back to their coverage, because there's fun info here. In particular, last sentence, this complexity means that any infra changes require careful validation across all platforms and configurations. Supposedly, that means that these changes actually did negatively affect the other platforms. I don't know for sure, but it seems not unlikely. Here is the timeline as they describe it. Yellow is degraded, red is fucked, and green is fixed for the 3 different issues that they had. Starting August 5th, they had a context window routing error, which affected around 1% of Sonnet 4 requests. That's brutal. That there's a 1 in 100 chance that your request gets routed to the wrong place and it performs worse. The reason for this was the recent introduction of the 1 million token context windows in Claude models. If you haven't paid much attention to the performance of models when you increase token amounts and when you increase context size, the performance tends to go down very quick. It's called the needle in the haystack problem, but it goes much further than that. When you give a model more context, the quality of its outputs goes down. My assumption here is that the 1 million token version of Claude 4 Sonnet probably had less than ideal performance in general. Like the changes they made to allow it to handle 1 million tokens made it dumber in general. And the bug, as they detail here, is that it would send traffic to that version when it shouldn't have, even if it was well under 1 million tokens. Then on August 25th, the output corruption error started. On August 26th, they had a top K code hack they did that broke a bunch of stuff. August 29th, they made load balancer changes that caused 16% of Sonnet 4 requests to get routed incorrectly. And from August 29th to September 4th, those problems were persistent. They did manage to fix the corrupted output issues a little earlier on September 2nd, but then this other bug took until September 12th. So it took them a while to fix these things. Let's talk about those different bugs. The overlapping nature of these bugs made diagnosis particularly challenging. The first bug was introduced on August 5th, affecting approximately 1% of requests made to Sonnet 4. 2 more bugs arose from deployments on August 25th and 26th. Although initial impacts were limited, a load balancing change on August 29th started to increase affected traffic. This caused many more users to experience issues while others continued to see normal performance, creating confusion and contradictory reports. 3 overlapping issues. First one is the context window routing error. On August 5th, some Sonnet requests were misrouted to servers configured for the upcoming 1 million token context window. This bug initially only affected 1% of requests, but on August 29th, a routine load balancing change unintentionally increased the number of short context requests being routed to the 1 million context servers. At the worst impacted hour on August 31st, 16% of Sonnet 4 requests were affected. Approximately 30% of Claude Code users who made requests during this period had at least one message routed to the wrong server type, resulting in degraded responses. On Amazon Bedrock, misrouted traffic peaked at 0.2% of all Sonnet 4 requests, and incorrect routing affected less than 0.0004% of requests on Google Cloud's Vertex AI between August 27th and September 16th. Again, it did affect the other providers, but significantly less than Anthropic. No conspiracy theories just yet. We'll go into my conspiracies soon. It is of note that some users were affected more severely. I'm almost certain I was, considering how bad of an experience I was having at the time. As our routing is sticky, that meant that once a request was served by the incorrect server, subsequent follow-ups were likely to be served by the same incorrect server. This is so that if you're caching context, you don't have to wait as long for it to load. So when I send a message, get a response, and then send another, it's more likely that you're hitting the same server, so it's more likely that it already has the context cached for the things you just said before, and it can continue accordingly. That's a good thing. It's not good if the server you hit is bad and now you're stuck to the bad server. Resolution. We fixed the routing logic to ensure short and long context requests were directed to the correct server pools. We deployed the fix on September 4th. Rollout to our first-party platform as well as Google Cloud's Vertex AI was completed by the 16th and to AWS Bedrock by the 18th. Issue number 2, output corruption. On August 25th, we deployed a misconfiguration to the Claude API TPU servers that caused an error during token generation. An issue caused by a runtime performance optimization occasionally assigned a high probability to tokens that should rarely be produced given the context. For example, producing Thai or Chinese characters in response to English prompts, or producing obvious syntax errors in code. If you don't already understand how LLMs generate stuff, I'll give a really brief and not great overview. So I take a prompt like, I don't know, generate solutions for advent of code in 4 different programming languages. You'll see that this is split into 13 tokens. A token is the way that your text is broken up, both your text that you give to the model and the model's generated output, in order for it to map all of these things in this giant, chaotic web of parameters. Notice that I just added a word because it spelled advent of code wrong. It did adventive code, not advent of code. And even though I changed this to be advent of code, it's still the same number of tokens. They're almost like, kind of like syllables, but it's not that clear a split. Now I delete the space at the end, we're now down to 12. Cool. And when it outputs things, the same thing happens. If we take some code that was generated, throw this at a model that's reliable, Grok 4 fast, not very fast anymore. Let's throw this in the tokenizer, and you'll notice it's split up a hell of a lot more because source code has a lot of tokens because it needs to be able to break it up in a way where it can generate the next piece. So the way the model works is it has all of these as parameters, often billions, if not trillions of parameters. So if we have words like the, cat, elephant, you pass it an input, and then it picks what it thinks the most likely token is to respond with. This is a parameter that it has inside of its crazy web of data. And then it has mappings to all sorts of other tokens throughout that are weighted. So each of these potential paths has like a number, 0.5, 0.8, 0.2. And all of the other tokens in the current generation change the weight of which points where. You effectively are traversing through this based on what it thinks is most likely based on the previous terms. So the cat sits on elephant, for example. From the most likely next thing was cat, 0.8. We have cat routing to all sorts of different things, but it thinks it's most likely to go to sits on elephant. And that's really roughly how the generation happens. And all of these weights are determined with math that determines, based on the previous inputs, what direction the text generation is most likely to go in. So the problem here was that the probability calculation, where it would determine what the next token should be, had some bad math in it. And that corruption resulted in certain unlikely tokens to be snuck into your responses. So in the middle of your English response to an English question, you might just get these random characters in the middle of the response. This corruption affected requests made to Opus 4.1 and 4 on August 25th through 28th, and requests to Sonnet 4 from August 25th to September 2nd. Third-party platforms were not affected by this issue. That is a very important detail here, because now we're going to start getting into some conspiracies. All of the changes Anthropic was making, other than the million token one, everything else they did was with a very specific goal in mind. Reduce compute per request. The easiest way to reduce the amount of compute a request takes is to make the actual model dumber and work cheaper. Ideally, you don't do that, and ideally Anthropic doesn't either, and I want to be very clear. They did not intend to make the model dumber. They did intend to reduce the compute that was necessary per request. And here's where the conspiracy comes in. I've talked about this a bit in other videos about Anthropic. They need more GPUs for the research side of things. The research team, the model training team, the data teams, all the other teams at Anthropic are competing with us as developers building on the API for GPUs right now. Anthropic was hoping to reduce the amount of GPUs necessary to handle the load from the API. If they can find a win that's like a 1% win in the compute necessary for a request, that's a lot of GPU they just freed up for their own research. And that is very clearly one of their specific pointed goals. How can we free up GPUs for the work that we are doing at whatever cost? And when you see how many changes they're making, which is why this timeline got so chaotic, you can see just how hard they are trying to do this. At every corner they can, they're finding ways to cut the amount of compute necessary in hopes of freeing up more allocation that they can then use for their research. That's also why a lot of these changes were kind of rushed out. I think that'll get extra clear with issue 3 here. The approximate top K XLA TPU miscompilation. On August 25th, we deployed code to improve how Claude selects tokens during text generation. This change inadvertently triggered a latent bug in the XLA TPU compiler, which has been confirmed to affect requests to Claude Haiku 3.5. We also believe this could have impacted a subset of Sonnet 4 and Opus 3 on the Claude API. Third-party platforms were not affected by this issue. They actually broke down this bug more in detail. To illustrate the complexity of these issues, here's how the XLA compiler bug manifested and why it proved particularly challenging to diagnose. When Claude generates text, it calculates probabilities for each possible next word, then randomly chooses a sampling from the probability distribution. We use top P sampling to avoid nonsensical outputs, only considering words whose cumulative probabilities reach a threshold, like 0.99 or 0.999. On TPUs, our models run across multiple chips, with probability calculations happening in different locations. To sort these probabilities, we need to coordinate data between chips, which is complex. The problem of having multiple different GPUs solving the same request at the same time is absurd. There's so much history there, especially with the chaos of the import bans for China. Maybe a video another time. Absolute chaos there, though. And that's the layer where these bugs were starting to happen. In December of 2024, we discovered that our TPU implementation would occasionally drop the most probable token when temperature was 0. We deployed a workaround to fix this case. You know the classic divided by 0? This is a hack for top P0, aka temperature is 0. Due to oddjacks issues, it's possible that probs greater than probs max -1, it's all false. So we manually always preserve the top logit in each row. This is the math that they did to handle when you have temperature all the way down. Temperature is a parameter that controls the randomness of a model's predictions during text generation. Higher temperature leads to more creative and diverse outputs, allowing for multiple variations in phrasing, and, in the case of fiction, variations in answers as well. Lower temperatures result in more conservative and deterministic outputs that stick to the most probable phrasing and answers. Adjusting the temperature enables users to encourage a language model to explore rare, uncommon, or surprising word choices and sequences, rather than only selecting the most likely predictions. Again, with my little diagram here, if we're following the tokens down the different paths that are the most likely, you end up with something kind of deterministic because it's going down the highest number for each thing. The gap here barely matters. Actually, the second one's slightly bigger. So let's 99989 versus 99987. If you have the temperature turned all the way down to 0, or you don't have a concept of temperature, you just always pick the best one. But temperature is effectively letting you randomize and say, no, it's okay to pick something really close, which lets you get more variation in your outputs. Most model providers have the top P or the temperature set as a 1.0 or 0.8, usually. Just the number that determines how much wiggle room to give when it's doing this math. And the mistake they made is that their math here appears to be broken. The root cause involved mixed precision arithmetic. Our models compute next token probabilities in BF16, which is a 16-bit floating point number. However, the vector processor is an FP32 native, which is a 32-bit float. The CPU compiler, which is XLA, can optimize runtime by converting some operations to FP32. This optimization pass is guarded by the XLA allow excess precision flag, which defaults to true. This caused a mismatch. Operations that should have agreed on the highest probability token were running at different precision levels. The precision mismatch meant that they didn't agree on which token had the highest probability. This caused the highest probability token to sometimes disappear from consideration entirely. Fun. On August 26th, we deployed a rewrite of our sampling code to fix the precision issues and improve how we handle probabilities and at the limit that reach the top P threshold. But in fixing these problems, we exposed a trickier one. Here's their new test file. Code snippet showing a minimized reproducer merge as part of the August 11th change that root caused the bug being worked around in December 2024. In reality, it's expected behavior of the XLA allow excess precision flag. Our fix removed the December workaround because we believe we'd solved the root cause. This led to a deeper bug in the approximate top K operation, performance optimization that quickly finds the highest probability tokens. The approximation sometimes returned completely wrong results, but only for certain batch sizes and model configs. The December workaround had been inadvertently masking the problem. This is very clearly a Slack screenshot that they just snuck in here. They haven't named accordingly. Nope. Are they running this on Vercel? Nope, it's Google Cloud, but they are using Next. Sorry, I get nerdy about those details. The bug's behavior was frustratingly inconsistent. It changed depending on unrelated factors, such as what operations ran before or after, and whether debugging tools were enabled. Those are the best bugs. When you turn on debugging and it behaves different, fun. The same prompt might work perfectly on one request and fail on the next. While investigating, we also discovered that the exact top K operation no longer had prohibitive performance penalties that it once did. We switched from approximate to exact top K and standardized some additional operations on FP32 precision. Model quality is non-negotiable, so we accepted the minor efficiency impact. Happy that they're finally putting this in words. I will hold them to that comment. So why was detection so difficult? Our validation process ordinarily relies on benchmarks alongside safety evals and performance metrics. Engineering teams perform spot checks and deploy to small canary groups first. These issues exposed critical gaps that we should have identified earlier. Evaluations we ran simply didn't capture the degradation that users were reporting, in part because Claude often recovers well from isolated mistakes. Our own privacy practices also created challenges in investigating reports. Our internal privacy and security controls limit how and when engineers can access user interactions with Claude, in particular when those interactions are not reported to us as feedback. This protects user privacy, but prevents engineers from examining the problematic interactions needed to identify or reproduce bugs. Privacy and reliability are often at odds, and this is a good example of that. That said, they should have been able to catch it internally. Each bug produced different symptoms on different platforms at different rates. This created a confusing mix of reports that didn't point to any single cause. It looked like random, inconsistent degradation. That is also how it felt as a user. I had so many weird problems with Claude during this window. More fundamentally, we relied too heavily on noisy evaluations. Although we were aware of an increase in reports online, we lacked a clear way to connect these to each of our recent changes. When negative reports spiked on August 29th, we didn't immediately make the connection to an otherwise standard load balancing change. That one's a little harder to forgive. So let's see what they're doing about this. As we continue to improve our infra, we're also improving the way that we evaluate and prevent bugs like those discussed above across all platforms where we serve Claude. Here's what we're changing. Ignore the cat. He has needs. Change 1. More sensitive evaluations. To help discover the root cause of any given issue, we've developed evaluations that can more reliably differentiate between working and broken implementations. We'll keep improving these evaluations to keep a closer eye on model quality. Change 2. Quality evals in more places. Although we run regular evals on our systems, we will run them more continuously on true prod systems to catch issues such as the content window loading balance error. Context window, same difference. You get the idea. And then change 3, faster debugging tooling. We'll develop infrastructure and tooling to better debug community source feedback without sacrificing user privacy. Additionally, some bespoke tools developed here will be used to reduce remediation time in future similar incidents, if they should occur. Also notice that nothing here mentions refunds for affected customers. Over 30% of Claude Code users were affected, and approximately 0% of them got any money back or anything back as a result. Evals and monitoring are important, But these incidents have shown that we also need continuous signal from users when responses from Claude aren't up to the usual standard. Reports of specific changes observed, examples of unexpected behaviors encountered, and patterns across different use cases all helped us isolate the issues. It remains particularly helpful for users to continue sending us their feedback directly. You can use /bug as a command in Claude code, or use the thumbs down button in the Claude apps to do so. Developers and researchers often create new and interesting ways to evaluate model quality that complement our internal testing. If you'd like to share yours, you can reach out to them directly. There are things I would like them to change. I wish that they were more transparent as these things were happening. I wish that they did this type of posting more often. And most importantly, I wish that they owned this in a way where they were actually refunding people, or if they just extended everyone's Claude Code subscription by 2 weeks as an apology. There's a lot of things they could have done here to own this better, and I am surprised they didn't take those opportunities. But at the same time, Anthropic is as much an optics company as they are a actual tool we can rely on. So it's not surprising to me that they went the optics route here. All that said, this article represents a significant change at Anthropic. This is a level of transparency I just would never have expected from them before. I'm very thankful they're finally out here doing it. And I don't want to be too mean because I really want to encourage that they continue doing this. As we build more and more things on top of the non-deterministic, unreliable chaos that is LLMs, it is more important than ever that the companies providing those are really transparent about what they're providing and what went wrong with what they're providing, because none of this is deterministic. We don't know what to expect. So if things are less than what is expected, they need to overcompensate by doing more communication on top. Anthropic historically hasn't done this because they're still not used to being a tool people rely on. They're really just a research company at heart. And as much as I love and respect that, we do now rely on Anthropic as an infra company, and they need to step up to the plate and own these things when they happen. I got nothing else on this one. I hope this was a useful breakdown. Let me know what you guys think. And until next time, peace nerds.